So we're going to talk about symmetry of quadrilaterals today. And we need to go back and refresh our memory about a few characteristics with regard to parallelograms, rhombuses, squares, rectangles. And the thing is, for a quadrilateral, remember that a quadrilateral with opposite sides that are parallel is a parallelogram. And not only are they parallel, but they are also congruent. The sides are also congruent. Some other features to remember. A parallelogram, with regard to a rectangle, a parallelogram has 4 right angles. And the thing is, opposite sides are also congruent. If we're dealing with a rhombus has 4 sides, and they are all congruent. And then finally a square. Well, a square is a parallelogram, it's a rectangle, it's a rhombus. But the features that we want to remember when we get into symmetry here in a couple minutes are, it's a parallelogram with 4 sides that are congruent and 4 angles that are right angles. So those are some of the features that we need to remember as we look at our symmetry. So we want to determine if the following figures have line symmetry. If yes, we're going to draw in all the lines of symmetry and state the number. Our first one, when you stop and think about it, there's really only 2 ways to draw in the lines for something to be symmetry. We can draw in a vertical line, and that was a terrible line. I'll try one more time. Right down the middle, and I still missed that a little bit. Scoot that over. Right down the middle. If we fold that rectangle along that blue line, the right side of the figure will land on the left side. And there's also a horizontal line in there. If we fold the top part of the rectangle over the horizontal line, it will land on the bottom part. I was thinking here, or I was wondering if the diagonals in this figure would be symmetry. And the answer is no, because what happens here, if we folded it along the diagonal, and I don't write this down because I'm going to want to erase it, but what happens is, if we folded it along the green line here, is that when we folded it, the short side would land on the long side. So it's not going to be the diagonals in here. In any rectangle here, and I'll have to draw it again because I want that erased, but in any rectangle, the only lines of symmetry are the horizontal and the vertical lines. And the directions say, determine if the following figures have line symmetry. If yes, draw in all lines of symmetry and state the number. Well, we've got 2 lines of symmetry. If we look at a rhombus here, the thing about the rhombus here that we have to remember in terms of features back from our previous studies is that this angle here and this angle there are supplementary. So we can't draw a line kind of right down the middle. It seems like we could, but this angle, when we map over to there, won't land on that angle there. So that line that I have drawn in there is not a line of symmetry. But we can get two lines of symmetry here if we draw in the diagonal and we draw in the diagonal. If we fold this over, we also need to remember that opposite angles are congruent. So this angle would land on this side. Let me point that out. This angle would land over here, and those ones are congruent. Those are our only two lines of symmetry. We can't draw in a horizontal or a vertical. We look at a square. Well, the nice thing about a square is that a square is classified as a rectangle. It's also classified as a rhombus and also a parallelogram, but the previous two figures that we just did are part of our determining if something is a square, which means that if we take the features of a rectangle, we can draw in the line of symmetry here and the line of symmetry there, which comes from the rectangle. The nice part is that a square also has four congruent sides, so we can draw in, hopefully your line is better than mine, the diagonals. And on a square, then, what we can say is that we've got four lines of symmetry. And just something to also refresh your memory about is that a square is a regular figure. It's a regular polygon, I guess, is what we called it. Oh, got to spell it right. Remember that a regular polygon means that we've got four congruent sides and we've got four congruent angles. And that's going to help us when we look down here at rotational symmetry momentarily. But our last figure here is the parallelogram. And the thing is, again, we need to be really careful with angles. Opposite angles are congruent, but adjacent angles, which are side-by-side angles, they're supplementary. So we can't draw a line, a vertical line in there or a horizontal line and get symmetry. Nor can we draw in the diagonals and have it land on the other side. And consequently, what happens is that there's no lines of symmetry. Oh, no lines of symmetry in our parallelogram. So again, just to refresh our memory, rectangle, always going to have two lines of symmetry. Rhombus, always going to have two lines of symmetry. Square, always going to have four lines of symmetry. And a normal parallelogram is going to have no lines of symmetry every single time. The other kind of symmetry that we've talked about in the past here is rotational symmetry. So it says determine if the following figures have rotational symmetry, and if yes, determine the order and the angle of rotation. And I just now see that I spelled angle as angel again. But remember, when we're looking at rotational symmetry, what we do, at least what I can do here, try to do this a little bit better, is I'm going to outline the rectangle. And once I do, remember, if we turn this, so we don't land on the rectangle there, but if we turn again, we do. Turn turn, we don't. Turn, we do. There's the rotational symmetry. And what happens is we were able to land on the same figure twice. And to figure out the angle of rotation, the formula that we use and we're going to continue to use is we take 360 and we divide by the order, which is 2, which gives us 180 degrees. Remember that angle of rotation has to be less than 360. Let's look at our rhombus. Again, highlighting it. And I'm a little bit off on my picture, but let's see. If we, oh darn it. If we turn, we don't land on it. There's one turn. Oh, but we do land it on there. Turn again, we don't. But turn another time. So once again, we were able to map the figure onto itself twice. And what we do to figure out the angle of rotation then is we take 360 divided by 2. On the square. Oh dear. I don't know what will happen here with my picture, but as we try to, here, turn this, oh no, come on. As we turn, we landed on it. We landed on it again. We landed on it. We landed on it. In other words, every single time that we turn here, all 4 times, we landed on it. And to figure out the angle of rotation, we're going to take 360 divided by 4. And 364 divided by 4 is 90. So let's see what happens with the parallelogram. We don't have any lines of symmetry here. So let's see if we have any rotational symmetry in this one. We turn it once, we don't. But if we turn it a second time, we do. If we turn it a third time, we don't. But when we go full circle here, we do. It turns out that we do have rotational symmetry, even though we don't have line symmetry in a parallelogram. 2 times we mapped the figure onto itself. And once again, to figure out the angle of rotation, we take 360 divided by 2. And we get 180 degrees. So there's the basics of the line symmetry and the rotational symmetry. Not a new concept for us. But let's look at some OST type questions here on the back. And the first one says, a rectangle is graphed below, or beside there. Determine which of the following transformations would map the figure onto itself. And select all that apply. So one of the things that I found helpful for me, that might be helpful for you, is I outlined rectangle here. Because we know some features about rectangles that might help us answer these questions. But another thing here is we look at letter A. It says a reflection over the y-axis. Maybe we draw a line along our y-axis. If we fold that red rectangle in half, will the right side of the graph land on the left side? And it will. And if you look, 1, 2, 3, 4 away, 1, 2, 3, 4 away. 4, 1, 2, we have to go the other way here. 1, 2, 3, 4 away. 1, 2, 3, 4 away. So I wonder, do we have anything that says reflects over the x-axis, since we're thinking about it? And it's letter F there. If we draw in our x-axis, if we fold this graph, does the top part of the rectangle land on the bottom part of the rectangle? Well, that point is 3 spaces away from that green line, and 1, 2, 3 spaces away from the green line. And it happens on both sides. So yes, it's also a reflection over the x-axis. Now be careful about letter B here, because there's another reflection. It's the reflection over the line y equals x. But this picture isn't quite square. So remember, if it's not quite square, start at 0 and do the slope of 1 over 1. Up 1 to the right 1, up 1 to the right 1. And as we draw this in, even before we finish, you can probably see that this is not a reflection over the line y equals x. And if you go back to what we did originally here, on the lines of symmetry, we don't have diagonals in a rectangle. It wasn't symmetric over that line. So even if we did go through the corners of that rectangle here, it still is not a reflection over the line y equals x. So now, when we look at the rotations here, oh, by the way, since I have one other reflection here, if it's not a reflection over the line y equals x, it's not going to be a line of reflection over the line y equals negative x. But we've got 2 rotations now. So we've got a rotation of 90 degrees about the center of the figure, and we've got a rotation of 180 degrees about the center of the figure. And I don't know if I can go back here again on my rectangle, but I might try here. What do we have on this one? Oh. When we tried to rotate, it didn't work here. There's one, and then we went here, and there's another. We don't have anything about rotation of 90 degrees, but we do have rotation of 180 degrees. So it's not 90, but it is 180. So A, D, and F on example 3. If we look at number 4, parallelogram. Again, up to you. I find it helpful just because we know some features of parallelogram, and if nothing else, we can flip our paper over and we can look back at some of the other characteristics of parallelogram to help us decide what we need here. But if we deal with the reflections first, because those are a little bit easier, this one says a reflection over the line PR. Well, this is parallelogram. Were we able to draw any lines of reflection in for lines of symmetry in for parallelogram? No. So even though I just drew that in, we don't need that. I'm going to erase that. Hopefully you didn't draw it in. Another reflection. Reflection over the line QS. Well, it's not working for PR. It's not going to work for QS. And again, we don't have any lines of symmetry for a basic parallelogram, so it's not going to be a reflection over the y-axis. And even when you draw that line in, I hope that you can look at that and go, oh yeah, that's not going to work. So now we have to go back and look at the rotational symmetry. And have we ever talked about rotational symmetry for 45 degrees? No. It's not going to be a rotation of 45 degrees. So we've got 2 choices here. We've got a rotation of 90 degrees about the figure, and we've got a rotation of 180 degrees about the figure. And that's when we flip our paper back again and we look at our parallelogram. And when we turn it here, there's 90. Doesn't work for 90, but it does work for 180. there's 270, and then there's 360, full circle. So, but it takes us 180 degrees to rotate. So that helps us answer this question here. It's not going to be 90, and it is going to be 180. It does say select all that apply, but this one happens to only have one answer in it, and that's allowed. And as we finish, so this last one here is a rhombus. And up to you. You can start at the beginning. You can look at the reflections first. But the first one says a rotation of 90 degrees about the center of the figure. If we go back to rhombus, one more. And my picture is not very good here, but if we turn this, there's 90, there's 180. So there's a 90, there's a 180 again. So it's not going to be 90. So it's not 90. Do we have 180? The thing is, we've got two 180s. We've got 180 degrees about the center of the figure, or we've got 180 degrees about the origin. The origin being here, if we rotate it around that point, is it going to be symmetric? It has to be around the center of the figure. And now we can go back and we can look at the reflections. A reflection over the y-axis. Well, here's the y-axis, even though I missed it a little bit with the disorientation. Are we going to be symmetric over the y-axis? No. So it's not that one. So that leaves us with the reflection across the line, WY. If we fold this graph in half, will the top part of the rhombus land on the bottom part of the rhombus? Yes. If we go across the line, XZ. If we take the right side of the rhombus and we fold it across the line XZ, will it land on the left side of the rhombus? Yes. So C, E, and F.